Hello everyone, welcome to Python lecture, and in this lecture I'm going to talk about bitwise OR operator. In my previous lecture I have already discussed about a bitwise AND operator. So this is the extension of the previous lecture. So let's try to understand guys one by one. So here let's suppose if I'm going to write 12 pipe means OR operator, or maybe let me write down the headings first of all, OR operator. Okay, fine. Let's suppose if I'm going to write down over here 12 pipe 23 execute. Now the answer is going to be 31. So how we are able to get this particular answer? And this pipe operator has been used as a OR operator. So before understanding this entire logic, we have to understand OR table in a very first place. So let me draw OR table for all of you. So here if we have OR table, let's suppose we have a OR table and we have input A and then B and then we have an output O. So this is how OR table looks like. If A is equals to 1, B is equals to 1, output is going to be 1. If A is equals to 0, B is equals to 1, output is going to be 1. If we have A is equals to 1, B is equals to 0, output is going to be 1. If A is equals to 0, B is equals to 0, output is going to be 0. So this is how OR table looks like. And based on that, this entire calculation is going to happen. Based on that, based on like a bitwise obviously, and based on the binary conversion of this particular number. So let's suppose if I have to convert this 12 into a binary. So I can write bin over here, right? I can write bin over here and then I can try to write down 12, execute. So this is a binary equivalent of 12. Now what is a binary equivalent of 23? So binary equivalent 23 is basically 10111. Now let's do our manual calculation. So here, if binary equivalent of 12 is basically 1100 and binary equivalent of 23 is 10111. So binary equivalent of 23 is 10111. Fine, place it 0 over here. Now we are going to do pipe operation, or we are going to do OR operation based on this particular table. So 0 1, so 0 1 going to be 1, 0 1 again going to be 1, 1 1, so 1 1 going to be 1, so 1 1 going to be 1, 1 0 1 0 going to be 1, so yes it's going to be 1, 0 1 is going to be 1, so it's going to be a 1. Now this is the final outcome. If I'm going to convert this binary number into a decimal equivalent, you will be able to see the final outcome, which is 31, right? So in this case, we have received answer is equals to 31. So let's do it guys quickly. So I believe we all know the function name. So we can try to call int over here. We can try to pass this 11111 as a string in this particular place, and then base is equals to 2. Execute, and we are able to get 31 as an answer. So here, yes, we are able to do this calculation even by using this particular table in a manual fashion. Now I'm going to take another example, because this example is the simplest one. Wherever we have a positive number, it's a simple example, right? So most of us get stuck with respect to a negative number. So let's try to understand how this calculation happens with respect to negative number. So here I'm going to write 14 and then pipe 23, execute. The answer is going to be -9. So let's try to do this calculation, and you all are going to enjoy, believe me, you all are going to enjoy this particular calculation, because here even output is negative. So you all will get stuck at some point of a time while doing this kind of a calculation. But I'll try to explain you in a very, very simple manner, believe me. You just have to focus over here for next 5 minutes and you will be able to understand these things for your entire life. So here, what is the binary equivalent of 14? 14. I have a negative 14, but I'll try to calculate for 14 as of now. Then what is the binary equivalent of 23? So yes, I'm able to get binary equivalent of 14 and I'm able to get binary equivalent of 23. Now, even in my previous lecture, I told you that whenever there is a negative number, right? Whenever there is a negative number, system will try to convert this binary equivalent into a 2s complement, and then it is going to do a math or do a calculation. Yes. So for 14, if I have to represent 14, which is this one, into 32-bit, because I'm using a Python compiler, so obviously I have to take care of 32-bit, right? So that in a 4-byte, which is 32-bit, it will be able to store this entire data, or this 14 or minus 14. So here, this is a equivalent, binary equivalent of 14. So I'll try to take 32 as space. So 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and then 1, 1, 1, 1. So 1, 1, 1, and then 0. So this is a 32-bit representation of this number 14. Now I have to store minus 14, right? So first I'll try to find out 1s complement. What is the 1s complement? Just a reverse of this. Yes, just reverse this entire number and you will be able to get 1s complement. Means wherever you have 0, convert it into 1. Wherever you have 1, convert this into 0. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and then 0, 0, 0, 1. Fine. So this is 1s complement. Now 2s complement. So what is going to be 2s complement? So just add 1 over here and you will be able to find out 2s complement, right? And we all know the addition. If there is a 1, 1, so it is going to be 10. So 1, 1, 10. So 0, carry forward 1. So 1, 0, 1, then 0, then 0. And then in rest of the places we have 1. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay. So now this is basically minus 14. This is the number which system is going to store internally in a 32-bit. And the very first bit that you are able to see, it's called as most significant bit. So it always gives you a notation that my number is a negative number, always, right? So wherever you have 1, it simply means that I have a negative number. Wherever you have 0, it simply means that I have a positive number. So yes, this is the number that system is going to store after finding out 2s complement. Now, we have to do pipe operation. We have to do OR operation with 23. So this is the number, right? This is the number. So let me write down in a 32-bit format. So 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and then 1, 0, 1, 1, 1. So 1, 0, 1, 1, 1. Now this is a 32-bit representation of 23. Fine. We have to do pipe operation. So OR operation we have to do in between. So fine. Let's do OR operation, guys, with the help of OR table. So here 0, 1, 0, 1. Output is going to be 1, 1, 1, 1, 1. Output is going to be 1, 0, 1. Output is going to be 1, 0, 0. Output is going to be 0, 1, 1. Output is going to be 1. And then in rest of the places, we have 1, 0, 1, 0, 1, 0, 1, 0 in this fashion, right? So again, answer is going to be 1, obviously. So let's write down 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Fine. So now this is the final outcome that I'm able to receive. This is the final outcome. But if you are going to convert this number into its decimal equivalent, you will not be able to see the exact outcome, which is minus 9 in our cases. Why? What is the reason? As you can see that this is the final outcome and the very first bit is a 1. It simply means that that system will try to give me negative number. So if it is a negative number, right? If there is a 1, if there is a 0, you can directly convert it. But if there is a 1 as a first bit over here, in that situation, you have to again convert it into its 2s complement. So first you will be able to, you have to find out 1s complement and then you have to find out 2s complement. That is going to be the final answer with a negative sign. So here we have 1 means negative sign, but you have to find out 1s complement first. So what is the 1s complement? Simple. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0. This is basically 1s complement. Yes, this is 1s complement. Now, if I have to find out 2s complement, what I have to do? I have to add 1 over here. Now, this is going to give you the final answer with a negative sign. So here, 0, 1, 1. Just do the addition, 0, 1, 1, then 0, 0, 1. And then in rest of the places, right? Rest of the places, we have 0, 0, 0, 0, 0, 0, 0, 0, because I was trying to add this number with a 1s complement, right? Then you will be able to find out 2s complement. So 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, fine. Now this is the final output you will be able to get with a negative number, as the very first bit was a negative. If it would have been a positive number, in that case you don't have to find out the 2s complement. But if it is a negative, if very first bit is negative, you have to find out 2s complement, and that is going to be your final answer. So here, if I'm going to convert 1, 0, 0, 0, because the rest of the bit is basically 0, so this is the only bit that I have. So 1, 0, 0, 1. If I'm going to convert this one into a decimal equivalent, int, and then again in under the string 1, 0, 0, 1, and then base is equals to 2, you are able to get 9, like I said, minus negative, right? You have to take negative of it. So final answer is going to be negative, as the very first bit was 1. So this is how you are going to deal with a negative number when you are trying to give an input, as well as when you are trying to get output. In both the places, if there is a first bit which is 1, you have to take care of it. You have to find out a 2s complement, then only you will be able to give an answer. Otherwise, no, you will not be able to give an answer. I believe this is making sense to all of us. With that, thank you so much everyone. See you again in my next lecture.